Hello, sixth graders and parents of sixth graders. I'm going to try to go as quickly as I can through GCF and LCM. I got some requests for a little bit more help, so here we go. The first way to find the GCF, which is the greatest common factor, is to take the factors of each number that you're given and find the one that they have in common. So this Venn diagram here is actually somewhat pointless. The reason it's there is to show you what we're doing with the numbers, but I was telling the students in class, I don't ever use it because I'm kind of lazy. And so I showed them how you can see the answer without putting them in a Venn diagram. I'm going to go ahead and show you the exact same thing. So we take all the factors of 24. I'd say 1 times 24, 2 times 12, 3 times 8, 4 times 6, and those are all the factors. Now, using a multiplication table to find the factors is a really smart idea, especially if you struggle with your math facts. So you could go down the ones list and find 24. Now, everything works for 1, so hopefully you don't need to go down the ones list for anything. 2's also, most of you know your 2's if you can divide it by 2. But then once you get to 3, you can go down the list of 3's, and if you find 24, then you know it works. If you don't, you can skip over it. Let's do 18. 1 times 18, 2 times 9, 3 times 6. That's it. So for the Venn diagram, what I would be doing is I would be looking and saying, okay, 1 is in both of my lists, so 1 is a factor of both 24 and 18. 2 is in both of my lists, so 2 is a factor of both 24 and 18. 3 is in both of my lists, so I would put 3 in the middle here of my Venn diagram showing it's in both lists. 4 is only in this side, so I'm going to put it only on that side. 6 is in both of my lists, so I will put it in the middle. 8 is only on this side. 9 is only on this side. 12 is only on this side. 18 only on this side. 24 only on this side. Okay, I'm done with my Venn diagram. You noticed as we were making my Venn diagram, I bet, that you could see over here which number was the biggest number that they both had in their list. It is 6. The Venn diagram is just used to illustrate the fact that these are the numbers that they both have in common, and the greatest or the biggest of these is 6. So I'm going to ignore this Venn diagram for this one and show you how I don't really need it to find the greatest common factor. So I'm going to do the exact same method. I'm going to say 1 times 14, 2 times 7, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, so those are all of my factors. 28, 1 times 28, 2 times 14, 4 times 7, and that's it, okay? Right now, I bet you can see the greatest common factor. So we could just go through and circle all the ones that we see that they have in common. That's one thing we could do and say, which one's the biggest one we circled? 14. 14 is the greatest common factor. However, the smarter option, instead of going and starting at 1 and going through, is to start at the biggest number in the smaller group. So the biggest number from the smaller number, the biggest factor from the smaller number, and say, does this one work over here? Sure does. Done. I don't even have to look at anything else because I know if I start at the biggest, that the first one I find is going to be the biggest or the greatest common factor. Another method we can use is called the ladder method. I call it the upside down stairs method because it looks like upside down stairs. And what you do is you divide out a number that can divide both of the two numbers you were given. So I could divide both of these by 2, and I'd get 10 and 8 as the result. I could divide both of those by 2, and I get 5 and 4 as the result. I cannot divide anymore. I'm done. There's nothing else that divides 5 and 4. So I'm going to take what's outside of my stairs or my ladder, and I'm going to multiply it, and that is another way to find the greatest common factor. So let's do it again. Over here, 24 and 40, I'm going to divide by 2. I'm going to divide by 2 again. I'm going to divide by 2 again. And I cannot do anything else. So I'm going to go ahead and multiply these. 2 times 2 times 2 is 8, and that's my greatest common factor. Another way I like that I did not teach in class, I might show them today, another method. I'm not sure that giving them another method is necessarily helpful, but one other way that I have on your notes sheet is that you can use a prime factorization. So if I use prime factorization, you can see this is the same problem from the last page. I'm just going to I'm going to make a factor tree of all the things that multiply to be 14 with prime numbers. So I'm going to take any prime number. It doesn't actually even have to start with a prime number. You're just breaking it apart into a multiplication problem that equals 14. The only one I can think of is 2 times 7 because they're both prime. Circle the prime numbers, write it as a multiplication problem. 28. I'm thinking 2 times 14. So I'm going to circle the prime number. I can't do circle 14 because it's not prime. So I'm going to keep going. 2 times 7. Now all of my numbers are circled, and my multiplication problem is 2 times 2 times 7. I like to write these in order from least to greatest because they line up better when I put them on top of each other. So if I have this one here, I'm going to do 2 times 2 times 7 underneath it, and I'm going to circle the things in both lists. I have a 2 in both lists, I have a 7 in both lists, so I'm going to take the things that I circled, multiply them together, and the greatest common factor is 14. If I have 3 numbers, I can do it in any of the ways that I've already shown you. Let's do this first one as factor trees. I'm going to be lazy and do them right from here. So I'm going to say 3 times 6 makes 18. 2 times 3 makes 6. So I have 2 times 3 times 3. 24. I'm going to take, let's do 3 times 8. And again, you can do any problem that works. You'll get the same result. So I'm going to go ahead and put it over here. 2 times 2 times 2 times 3. Okay, and then 60. I'm going to go 6 times 10. 2 times 3. 2 times 5. Okay, and I'm going to go 2 times 2 times 3 times 5. So now I'm going to circle something that's in all 3. So I see a 3 in all 3. I see a 2 in all 3. And I don't see anything else that's in all 3 lists. So I'm going to take those 2 that I circled from all 3 of them, and the greatest common factor is 6. I'm going to do this one, the ladder method, or the upside down stairs method. I'm going to put them inside the stairs. This time I have to pull out something that's in all 3 of them. So I notice they're all divisible by 5. I'm going to go ahead and divide by 5. So 15 divided by 5 is 3. 30 divided by 5 is 6. 60 divided by 5 is 12. Okay. Now when I'm looking, I see that I could divide them all by 3. So I'm going to divide by 3. I get 1, 2, and 4. And now I'm stuck, right? There's nothing that I can divide all of them by except for 1, which doesn't get us anywhere, so we're not going to do it. All right, so on the outside, I've got 5 and 3. 5 times 3 is 15. My greatest common factor is 15. Moving on to least common multiple. Multiples are just skip counting. So if I take 4, I'd say 4, 8, 12, 16, 20, 24. When you get big numbers like 14, 18, my strong suggestion is that they use their multiplication table. So in the back of the planner, there's a multiplication table. Look down the row or the column of 14 and list them. 14, 28, 42, 56, 70, and 84. 18s, if I go down that list, 18, 36, 54, 72, 90, and 108. We need to understand what a multiple is to use least common multiple. The first method for least common multiple is to just do the exact same thing I was doing, list multiples. I suggest you list about 4 or 5 of them, and then check to see if they have any in common. If they don't, keep going with the smaller number because it's going to take your smaller number a lot more multiples to get to a bigger one. All right, so again, I have 4. So I'm going to rewrite the 4 just because I don't want to forget that it's a multiple of 4. So 4, 8, 12, 16, 20, 24. Okay? Now I'm going to go down the 9s. 9, 18, 27, 36, 45. Okay, I'm not there yet. So notice that there are no multiples in common, but I'm all the way to 45 here, and I'm only at 24 up here. So I'm going to keep going on my 4s list to see if I can reach one of these numbers that I haven't reached yet. So 24, 28, 32, 36, bing, bing, bing. I found 36. The least common multiple is 36. Another way of doing this is to just go down the list of 4s, go down the list of 9s, kind of run your finger down each line and see when's the first time you see one in common. 6s, again, I'm doing the same method, 6, 12, 18, 24, 30, 36, okay? Go down my 15s, 15, 30, well, stop. I see that they both have 30 on their list, so 30 is my least common multiple. I like using the ladder method the most for least common multiple because listing all those multiples is not my favorite thing to do. So this is a lot faster way is using the ladder method. You're doing almost the same thing you did on the last ones, only this time you multiply by the last row that's inside. So this first one looks really tricky because there's 2 numbers that don't have anything that you can pull out. So if you can't pull anything out, you're just going to take those 2 numbers, multiply them times each other, and that's what you got. Let's try that 6 and 15, just so we have another example with 2. So at 6 and 15, I noticed that you could divide 3 out of both of them. So I get a 2 and a 5. Okay? Now, what I was doing before was drawing that line. But when I'm done and I have nothing left, I'm going to include this last group. See how it makes an L? So it makes me remember least common multiple because it makes an L with the outside numbers in the very bottom row. So I'm going to multiply all of those together. 3 times 2 times 5, which is 30. And remember from the last page, that was the answer that we got, was 30 for those. If I have 3 numbers, this is a little bit different than greatest common factor as well. It doesn't have to come out of all 3 to pull it out. So let's just go ahead and see what can come out of all 3. I notice 3 can. So 3 divided by 3 is 1. 9 divided by 3 is 3. 15 divided by 3 is 5. And this happens to have nothing more that could come out. So I'm going to go ahead and multiply everything. 3 times 1 is 3, times 3 is 9, times 5 is 45. This is the type of problem that we would use these things for. If I'm trying to find the first time things are going to come together when they only happen so often, you'll see lots of problems like this for least common multiple. It's almost always the same situation, like something happens every so many days or every so many hours and something else happens at a different increment. And you want to find out when do they happen together. So this one says Will has piano lessons every 7 days and he has to babysit his little sisters every 3 days. If he had piano and he babysat today, how many days from now will he have both things on the same day again? So basically it's just asking us what's the least common multiple of 7 and 3. Okay? So I want to know, I could write this out. I could say, okay, here's today, right? And so then I'm going to go 7 more days, and then I'm going to put an X, and that's the next time I'm going to have those things. And I can do the same thing. So there's other ways I could figure this out, but that's kind of painful. I want to do it as quickly as I can. So I'm going to go ahead and do this one, the ladder method. I'm going to say, all right, 7 and 3. How many things can I divide out of there? Nothing. So I'm going to go ahead and say 7 times 3, which is 21. Uh-oh, I don't know what happened to my pen. Here we go. Nope. We'll change color. Oh boy. Well, it's just a little lighter. Sorry about that. So 21 days from now is the next time that they'll both happen on the same day. This one's a little different. It's talking about the biggest amount of treat bags. So this one, a lot of times it will say biggest or greatest, the most, and that's an indicator that it's going to be a greatest common factor problem. Martha's making Halloween treat bags. She wants each bag to have the same amount of each type of treat. If she has 36 Laffy Taffies, 24 Skittles, and 30 chocolates, what's the greatest amount of treat bags she can make? So it's asking me to find the greatest common factor here. I want to know between 36, 24, and 30, what's the biggest grouping I can have of all of those. So I'm going to go ahead and I could do any of the methods. I think I'm going to list the factors. So we're going to say 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. For 24, I'm going to do 1 times 24, 2 times 12, 3 times 8, 4 times 6. That's it. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So I'm looking for the greatest common factor, the biggest grouping I can have of all of them. So I'm going to start with my smallest number, 24, and I'm going to check, starting at this 24, is a 24 in all of the lists? It's not. How about 12? Is 12 in all of the lists? It's over here, but not over here. So it's not 12. Is 8 in all of the lists? 8 is not in any of the other lists. I'm going to go to 6. Is 6 in all of the lists? It's here. It's here. 6 is my greatest common factor. I hope that helped. There are a lot of YouTube videos for least common multiple and greatest common factor. Sometimes they call them a little bit different, like least common denominator, because that's another way that we use multiples, is to find the common denominator for adding and subtracting fractions. I hope this was helpful. Look forward to doing a review video at the end of this unit. It's a pretty short unit, so it will only be in a few more days. Have a good one. See ya.